Okay, so today we are talking about graphing, analyzing, and writing piecewise functions. So piecewise functions mean that we are going to cut graphs and we're going to glue them all back together. So they're usually two or more functions. So a function means, again, it has to pass the vertical line test. So if I sweep my pencil from left to right, I need to be able to touch the graph at only one point at a time. For this one, we are going to actually cut it into three pieces, okay? So we are looking at this equation of the graph from -2 to the left, so like here-ish, to this side. This will all be that equation. Then from -2 to 0, so that would be here. We don't really have these lines, like we're going to take them out in a second, but it just kind of helps us for now. Then we're going to have this equation, and then from 0 to the right, this will be this equation. So these three equations are linear. They're actually written in the form y equals mx plus b. And if we remember from 8th grade, m is our slope. So if it's positive, it's increasing. And if it's negative, it's decreasing. And then the b is where we begin. It's our y-intercept. Okay, so we're going to graph this piecewise function. So we're going to start at +2. Okay, so we're going to go up to 2 on our y-axis because that's how we begin. We always begin with the extra number. So start at +2. Our slope is positive, and it's a 1/1 slope because there isn't a slope there. So I would go up 1 and to the right 1. However, for this piecewise function, I want this part of the graph smaller than 2 for the x value. So this x value is 0, so I don't really care about this dot right here. I need to get over to this section. Since this inequality does not have a line underneath it, whatever dot we put on -2 needs to be an open circle. As we do this, you'll see more, and you'll catch on. Okay, so from my 2, I'm also going to go down 1 into the left 1, down 1 into the left 1. So now I first start to touch -2 for my x-axis. So this has to be an open dot, because again, there's no line with my inequality. Okay, then we'll continue on. Down 1 to the left 1, down 1 to the left 1, down 1 into the left 1, all the way across our grid. And then, there we go. Now these cute little lines helped us kind of visualize what was going to happen, but they are not necessary, so we are going to erase all of them. Okay, open dot at -2. Now, from -2 to 0 on this x-axis, I want to have the equation of y equals 1. So that is a horizontal line where y is 1. Okay, so our line will be here. Now we have to figure out if we have open dots or closed dots. Well, on -2, since there's a line underneath my alligator, it's going to be a closed dot. And then on 0, since there's a line underneath my alligator, there is a closed dot. So here's that. Now, sometimes these piecewise functions connect and sometimes they don't, and it's totally fine. Okay, so from 0 to the right, so all the way over here, we're going to graph this equation. So +5 means that we start on our y-axis at +5, and this will be an open circle because there's no line underneath my symbol. Now from that, my slope is negative, so I'm going to go this direction. So there's no up and then left. I'm going to go down 2 into the right 1 because my slope is -2/1. Down 2 into the right 1, down 2 into the right 1, all the way across my grid. Okay, now we got to answer our questions about our graph. And we're going to take it one piece at a time. So is this first guy have an increasing? Yeah, the whole thing is increasing. Remember, increasing is when we stand over here, we need to walk left to right across our grid. If we walk uphill, we're increasing. So there's definitely an increase from -infinity to -2. And since it's an open dot, it's going to be a parenthesis. We're not increasing here because this is a constant, and we are decreasing here. So for the next part, this is, again, a constant. This is a decrease. So it starts where x is 0. We always use the x values as a reference. And then to the right forever and ever, because that's what's happening, that is infinity. And then it's a constant with closed dots between -2, and 0. Okay, positive means above the x-axis. So we're going to get, again, one at a time. This guy doesn't have anything positive. This guy is all positive, and he has dots that are not touching the x-axis. So we include those in our answer. So he's positive from -2 to 0. And the union of this next graph, he is positive from 0. I don't know why I wrote a 2. I said 0. 0 to 2. It's not quite 2-ish, like 1.5. That's not quite correct, but we'll go with that. Now, 0 is not positive or negative, so we cannot include that even though it's part of the graph, so we put a parenthesis. Okay, negative. Well, we're negative on this guy the whole time, so that will be -infinity to -2. And we're also negative on this guy. We're just going to pick up where we left off, 1.5 to infinity. It's not 100% accurate, but it's pretty darn close. Okay, so again, here's what we're doing with piecewise functions. We are taking parts of each graph and we're gluing them together. So for this guy, let's say I'm specifically talking about the absolute value of x. So we know what that's supposed to look like. The parent function says that we start at 0, 0, and because if you move one space from 0, you're also moving one space, so it's got like this very distinct V pattern, and the same on the other side, because we can't move negative distances, right? So if I go -1, well, that is also one space from 0. So this is what the parent function looks like, which we talked about a few days ago. And the way that we get that, or how we can talk about it as a piecewise function, is we're going to take the equation of this line and the equation of this line, and we are going to glue them together. So for this side of it, we're looking at this line, which is given to us by the function -x. So we want this absolute value graph to have the -x graph from -infinity to 0, so numbers smaller than 0. Then we're going to chop off this side of the graph. Then for this half of the graph, we want to graph where x is positive. So y equals positive x. That will be a 1/1 slope starting at 0. That's this guy. But we don't want this tail at the bottom, so we're going to choppy him off too. And then we're going to glue these two pieces together to give us the graph of the absolute value of x. Now we do the same thing with parabolas. So if we have the absolute value of x minus 4, well, we have now shifted down 4, okay? But we want the absolute value. So what we're going to do is we're going to just graph the negative of this guy, and then we're going to graph him positively. So when we have him negatively, it actually changes and flips our parabola, so he's now above the x-axis. Then we're going to choppy off this section. And then when we graph him normally, we can see that it has shifted down 4, and we're going to choppy off anything below the x, thus giving us an absolute value because everything above x is our positive in our absolute value. So we take this part and we glue it to this part, and then we have this as our graph. Anyways, so don't forget when we talk about absolute value functions or piecewise functions, we need to remember that we have to break the absolute value into two equations, one where we get a positive answer and a negative answer, but to solve it. Anyways, let's go into the back. Because we have two possibilities for the answers for absolute values, we could go on a walk and be on either two spots. Okay, we are going to we already kind of did that. Let's look on this page. Okay, let's do this one. So we're going to sketch the graph of the piecewise function, and then we're going to analyze it. Okay, so we're going to have our invisible line at +2. So we're going to choppy right here. I'm just going to draw a light line right there so we can see. So we're going to graph this equation first, and I want that to be the smaller half. So this is the left, and then this is our bigger half, our right-hand side. So from this line. So the left is going to go this way, and then the right goes this way. Okay? We're going to just choppy them and glue them together. Okay, so this starts at -4, so we're going to go to the y-axis. We're going to go to down 1, 2, 3, 4, and we're going to put our dot. Our slope is positive, and this one doesn't have a line. So when we end up on this, we're going to make it an open dot. So from here, we're going to go +1/1, so up 1 into the right one, up 1 into the right one, but again, our open dot, and then we can go opposite, down 1 to the left one, all the way across. You get the idea. Okay, now we're going to erase our cute little invisible line that we don't need. We're going to graph the other one. So this one says y = 1 for this half, and it has to be a closed dot. So we go to where y is 1, which is here. So we can't graph here, but as soon as we get to that 2, that's when it's okay to graph, when x is 2. So this is what that means. When x is 2, then I want this graph. And then y = 1 is like this. So now we have the information. We are increasing here. This is our increase. So from -∞ to 2, we're increasing. We are decreasing nowhere. We are positive only here. This guy is below the x-axis. So that will be from bracket 2 to infinity. Now the reason I'm going to use a bracket on this guy is because he is above the x-axis. We are negative on this guy, so that will be -∞ to 2. And then we are constant on this guy. Oh, wait, never mind. Silly. That's not positive, that's constant. Okay, constant is 2 to infinity, and positive is none. Sorry. Okay, let's do one more. Yeah, this one. Okay, so when we have this one, we are going to graph it. Again, our number is at -1, so we can draw a nice little pretend wall at -1. Okay, so then we're going to graph the equation of this line. So we have to start at +3 on our y-axis. And then notice that this guy's got a bubble, so whenever we get to -1, we actually get to put a bubble this time. So our slope is 1, so up 1/1. We don't want to go to the right, we want to go down 1 into the left. And it actually touches here, so we're going to put a nice dart. Down 1 all the way across. Okay, I'm going to do some erasing and clean her up a bit. Okay, and now we're going to glue its other half to it. So this doesn't have an extra number, so it's going to start at 0. We can put a dot there, that's fine. And it's a +2/1, so we're going to go up 2 into the right 1, up 2 into the right 1, up 2 into the right 1, 2 into the right 1 here. And then we're going to go down 2, but since this one doesn't have the line under it, when we go to the left one, it's going to be an open dot, like that, because it still has to be a function. So we're increasing, well, we increase from the left here, and then we increase some more, so -∞ to infinity. We are not decreasing, and we don't have a constant. Okay, we are positive. Let's look at this guy first. So he's positive, -1, 2, 3, -3. And then it take, well, -3 to, we'll just do it one at a time. -3 to -1. And -1 to infinity. And then we are negative. On this guy, we're negative from -∞ to -3. And, what is that? -1 to 0. All right, let's do one more. All right, so now what we're going to do is we're going to graph the absolute value and we're going to rewrite it as a piecewise function. Okay, so that's kind of what we did before. All right, so the first thing what we want to do is we want to figure out this guy. So if I made a table of values, let's just pick some numbers. So let's go -3, -1, 0, 1, 3. We're going to plug those in and see what happens. Okay, so -3 minus 2 is -5, and the absolute value is 5. -1 minus 2 is -3, and the absolute value is 3. 0 minus 2 is -2, and the absolute value is 2. 1 minus 2 is -1, and the absolute value is 1. And 3 minus 2 is 1, and the absolute value of 1 is 1. Okay, so let's graph it. So we have a dot at -3, 5. 1, 2, 3, 1, 2, 3, 4, 5. -1, 1, 2, 3, 0, 2, 1, 1, 3, 1. Okay, so you can kind of see what's happening. 2 is an important one, so let's do this. So 2. 2 minus 2 is 0, and the absolute value of 0 is 0. So 2, 0. And then it looks like it's going to continue on. If you wanted to, you could check, like, let's pick 7. 7 minus 2 is 5, and the absolute value of 5 is 5. So we'll go 7, 1, 2, 3, 4, 5. Okay, so here is our absolute value graph. Okay, so now what we want to do is we want to write this as a piecewise function. So we're going to start with the left-hand side. So from here, and here's our choppy point. So we're going to just write linear equations. So we're going from -infinity to 2. So that means that I want my numbers that are smaller than 2. Now when you're making this, you can put your line on either one, it doesn't matter. And then on this side, we want our numbers that are bigger than or equal to 2. Again, it doesn't matter where you put that cute little guy. Okay, so now we just have to write the equation of each of these lines. So remember, we're writing the equation in the form of y equals mx plus b. So our b is where our line touches the y-axis. So let's just start with this guy. Our b touches at 2. We're just going to write it backwards. Now we just have to figure out our slope. Well, that's down 1 over 1, so that would be a -1 over 1x. Or you could just write -x. Okay, now this guy, we're going to continue him on. He also has a slope of 1 over 1, so we're going to keep going down 1 over 1, down 1 over 1. So he would touch the y-axis at -2, and he has a positive 1 over 1 slope, so x. Okay, there we go. We wrote the piecewise function for the absolute value graph of x minus 2. All right, if you guys have any questions, let me know. Have a great day. Bye.